Okay, welcome to Chapter 5, the Integumentary System. The integumentary system is composed of skin, hair, nails, sweat glands, and your sebaceous oil glands. The skin is the largest organ in the human body. Okay, the functions of the integumentary system, they're pretty straightforward. Protection. So our skin is your first line of defense. It protects your muscles, your internal organs from bacterial infection. Sensation, allowing you to be able to feel, touch, feel pain, unfortunately, but we need those pain receptors. We have tactile receptors. Okay, and then our body, our integumentary system is responsible for thermoregulation. Okay, remember thermoregulation is controlling the body temperature. So if it's too hot, right, if your body temperature goes up, what happens? Do you sweat sometimes? Yes, you do. You sweat because we have to. We have to get that heat out. As soon as that sweat comes out of your sweat glands, it evaporates. Thus bringing down the body temperature. And in turn, if your body gets too cold, sometimes you get goosebumps, right? And you shake, which is a methodology to get back to that perfect temperature. But the goosebumps play a role here. And what they do is retain heat. So, quickly, I'm just going to type out these examples, i.e., okay, sweat releases heat, okay, and then your goosebumps, they retain heat. All right, and then vitamin D synthesis. So our skin, when it's exposed to sunlight, that sunlight activates the synthesis of vitamin D. So I'm going to type that out as well, so make sure you're taking notes. Sunlight activates vitamin D synthesis. Why is that important? Well, you absolutely need vitamin D for survival. And one of the main reasons is because vitamin D, okay, let's put it this way. No vitamin D, right? These are the consequences. No vitamin D equals no calcium, no phosphorus, okay, which are needed for bone health. Okay, if a body lacks these properties, they could end up with a disease called rickets, which is weak bones. And usually the people with rickets are bow-legged. All right, let's go on. Okay, the structure of the skin. Now, the structure of the skin is pretty straightforward. There's two layers. Okay, you have your epidermis, the superficial layer, and the dermis. Okay, the epidermis is epithelial tissue. It's avascular, meaning it doesn't have any vascular tissue, no veins and arteries, so meaning that it's primarily dead. Okay, so the epidermis is significantly smaller. It's just this little layer in comparison to the dermis. The dermis right underneath is made of connective tissue, and it is vascularized. See all these veins and arteries? Great. All right, right underneath the dermis is technically this subcutaneous layer of tissue called the hypodermis. It's not, when we say that the skin is made out of two regions, it is, but there is a third region really called the hypodermis. All right, so the hypodermis is filled with important things like adipose tissue. It's there to absorb shock, insulate. It helps keep, your heat. It helps insulate your body and keep heat. Okay, it also anchors your skin to underlying structures, mostly muscle. All right, let's take a look at each one individually, and we're going to start with the epidermis. So before we can really get into the epidermis, let's talk about the cells that are found in the epidermis. Okay, most of the epidermis is keratinized, stratified, squamous epithelial tissue. Okay, so we know what stratified squamous epithelial tissue is. Okay, stratified means that it has more than one layer. Squamous means that it has those flat, squished cells, and it's epithelial tissue. Keratinized means that it has an extra protein called keratin. All right, so keratinocytes are found in the epidermis. They make keratin. They tend to fall off and shed off your skin every day. We have melanocytes that make melanin. Melanin is the pigment, one of the pigments found in skin. Melanin actually protects the nucleus from UV damage. And in other words, melanin protects our cells from potentially getting cancer. The more melanin the skin has, or the more pigment, in other words, the less likely the individual is to get cancer. So you can look at it this way: the darker the skin, the less likely it is for them to get skin cancer, or for us to get skin cancer, depending on how much melanin we have, right? All right, so that's an important factor. Dendritic cells. Dendritic cells are important. These are the star-shaped immune cells, and they kind of patrol the epidermis and protect your body. So they're kind of one of our first lines of defense against any kind of invader. If it gets into the epidermis and meets one of these cells, well, that's the end of that. The dendritic Langerhans cells, these guys will just phagocytose an invader. Okay, then we have tactile cells, also called Merkel cells. Basically, these are sensory receptors, and so we're going to take a look at those. All right, so there's 4 cells found in the epidermis: keratinocytes, melanocytes, dendritic Langerhans cells, and tactile Merkel cells. Now, the epidermis has 5 layers, and okay, so this is actually the deepest layer. I'm going to go from the deepest to the most superficial. All right, first one is called stratum basal. Next, stratum spinosa, stratum granulosum, stratum lucidum, only found in thick skin, like your hands and feet. Stratum corneum. Okay, so this is the deepest layer. Okay, that's atrocious. Okay, and this is, I'm just going to type because trying to write with that pen is just not working. Stratum corneum is it's the superficial layer. Okay, so how are you going to remember all of this? All right, so I'm going to show you a quick little way to remember this. Okay, so a way to remember this is as follows. Okay, so this whole thing says, come, let's get sunburned. Okay, come, let's get sunburned. is the best way to remember this. Okay, so come, let's get sunburned, and you clearly, the layers are going this way though, deeper. This is the most superficial layer. So really, if I was taking a needle and poking your skin, it's going to go this way. All right, so that's how you remember this. Come, let's get sunburned, and always remember that the superficial layer, the outer layer, is the corneum, and the deepest layer is the basal layer. All right, so speaking of the basal layer, let's go ahead and start. So here we have all the layers. Okay, see, the dermis is down here. And then we have the stratum basal layer. We have the stratum spinosum layer, granulosum, lucidum, corneum. Or come, let's get sunburned. Okay, the basal layer is down here. It's the deepest layer, and it's the closest to the dermis. Now, it's attached to the dermis, and it has these stem cells there. We need them because we need all of the other layers of skin above the basal. We need cells up here, right? We need these cells replaced constantly. And guess who's responsible for doing that? The stratum basal layer. So they make cells through mitosis, mitotic division. One daughter cell will move into the surface, and one cell will stick behind, and it will be a stem cell. It'll remain a stem cell and make more cells. So in other words, the stratum basal makes all of the cells that supply the other layers through mitosis. Stratum spinosum is also referred to as the prickly layer. Okay, and I have a couple of pictures here because I want to show you why it's called the prickly layer, and it's not exactly demonstrated in this picture. It's demonstrated in this picture down here. Oops. All right. So right here, see this whole layer is the stratum spinosum. Okay. And remember we mentioned that there were dendritic cells, and we also mentioned melanosomes and things like that. Some of the cells of the epidermis. Well, specifically, basically these cells that are in there, they appear spiky looking. They look prickly, and therefore see the little kind of star shape. So it gives it this kind of prickly appearance, and that's where the name spinosum, aka prickly layer, comes from. So this is the second layer, the stratum spinosum. Okay, it has melanosomes to make melanocytes, and then it has dendritic immune cells. So if anything really does get through, and it does all the time, if it gets through all these layers, by the time it gets here to the spinosum layer, there's gonna be some response. The melanocytes, or the melanosomes, the melanocytes, they're more, responsible for making melanin, but the dendritic cells, they will come out. They will come out and they will start attacking the invader. Okay, the stratum granulosum layer. Stratum granulosum, really straightforward. It's about 4 to 5 to 6 cells thick. So, and the reason why it's called granulosum is because if you zoom in, and take a look at these cells they have little granules inside of the cells, thus giving it its name, granulosum. All right, it's very, all of these are flattened squamous cells. This is a thinner layer, and ultimately anything above this layer is technically dead. So it's just too far away from all of the vascular tissue, which vascular tissue is way down here in the dermis. So the vascular tissue can supply enough nutrients to where it'll reach the first two layers. The first three layers. After that, everything above that, lucidum, corneum, they're dead. Okay, stratum lucidum. Now, it's this little tiny clear layer, and it's only found in thick skin. And I'm just going to draw a line across. Okay, all right. It's thin, it's translucent, meaning you can see right through it normally and under the microscope. This image is just a sketch. In reality, if you looked at a slide, you would see this little thin band instead of this red band. It would be clear. Okay, and it's found again only in thick skin. So that means the palms of your hands and the palms of your feet. Okay. Stratum corneum is the outermost layer. It's also referred to as the horny layer because of the shape of the cells and the kind of shape that they make and the appearance that they give under the microscope. Because some of them are flaking off, they look like that. They look like little thorns. Okay, so these are anywhere from 20 to 30 rows of flat, keratinized, anucleated dead cells. And that's interesting that they're anucleated, meaning that these are another cell that lack a nucleus. Okay, now, even though these cells are dead, they still have a big job. They protect the other layers. They protect your body from the environment. They prevent water loss. They prevent abrasions, penetration. They are a barrier against biological and chemical and physical assaults. So anything that comes near your body that's dangerous, at least the stratum corneum is there to protect it. Now, okay, so let's kind of recap that. This is the epidermis, and the outermost layer to the innermost layer is called stratum corneum, lucidum, granulosum, spinosum, basal. Okay, and a great way to remember that is come, let's get sunburned. Basal, the innermost layer, is responsible for making new cells, right? The spinosum has a kind of spiny look because we have our dendritic cells here. The granulosum has granular cells here. The lucidum is found in thick skin. The corneum is keratinized dead cells that are anucleated and protect the underlying layers. Okay, so the next thing we're going to do is quickly watch this video on the epidermis.
The epidermis is the tough, leathery outer surface of the skin, ranging in thickness from 0.06 to 0.6 millimeters, with the thickest portions located in the palms of the hands and the soles of the feet. The epidermis is arranged in 5 layers that represent different stages of cellular differentiation. As new cells are formed, older cells elongate and their membranes thicken as they are pushed upward into the next epidermal layer. Let's explore these layers by clicking on the tabs to your left. The deepest layer, the stratum basale or basal layer, is attached to the dermis below by a thin acellular basement membrane. The basement membrane acts as scaffolding for the epidermis and as a selective filter for substances moving between the epidermis and the dermis. The epidermis is avascular, receiving its blood supply through the diffusion of nutrients from the dermis across the semi-permeable basement membrane. The stratum spinosum is the next layer. It consists of several rows of more mature keratinocytes, which appear spiny under a microscope. Just above the stratum spinosum is the stratum granulosum. This layer contains 3 to 5 flattened cell rows with increasing concentrations of keratin. As the stratum lucidum is a thin, clear layer of dead skin cells in the epidermis and is named for its translucent appearance under a microscope. The stratum lucidum is found beneath the stratum corneum in areas where skin is thicker, such as the palms of the hands and soles of the feet. The outermost layer of the epidermis is called the stratum corneum or horny layer. This layer consists entirely of dead keratinocytes. The stratum corneum can be 20 to 30 cells thick. The keratin in these cells helps keep the skin hydrated by preventing water evaporation. These cells can also absorb water, further aiding in hydration. This explains why you experience wrinkling of the skin when your fingers are immersed in water for long periods. There are a variety of cells located in the epidermis.
Okay, so the next thing we're going to talk about is the dermis. The dermis is the bottom layer of the skin, and it takes up the majority of the surface area. So it's about 80% of the skin is made up of the dermis. The dermis is then composed of 2 layers, the papillary layer and the reticular layer. Notice that the papillary layer is really, really small, thin-ish, and it's connected to the epidermis. And if we were to lift the epidermis, and you follow my pen, you'll see that the papillary layer makes these finger-like projections underneath, and it goes all the way around. So it kind of looks like a little egg crate. That is the papillary layer. Underneath is the reticular layer in pink, and the reticular layer is primarily composed of collagen and elastic fibers. Now, there's some other components to the dermis that are incredibly important. So let's go ahead and start with, we will start over here, appendages of the skin. So if we look closely, first we have our sweat gland, and this one is called the eccrine sweat gland. And if you look at it, you'll see it's kind of knobbly, twisted, convoluted tubule, and it allows sweat to exit through the sweat pore. Okay, next is the hair root. The hair follicle and hair root. All right, so all of this is technically the hair follicle. Okay, clearly this is the hair shaft up here. Now inside, connected to this hair follicle, there's several important structures. Okay, now the first one is this cluster. Okay, and what it actually is, it's our oil glands. So these are your sebaceous oil glands. Okay, now notice that connected to the hair follicle, underneath you're going to see, inside of the hair follicle, you'll see the hair root. And notice these little neurons right here, these nerves. These are hair follicle receptors. Okay. Additionally attached to the hair follicle is this muscle. This is called the erector pili muscle. Every single hair follicle has a small erector pili muscle attached to it. And that erector pili muscle is part of the reason why we get goosebumps, and part of it contracts and makes your hair stand on end and things like that. So therefore it has a role in sensory. Okay. Now, the other things that we need to cover here is you'll see sensory nerve fibers with free endings. How do you know they're free endings? Because they have this branchy type ends, and they're closer to the epidermis. Okay. This is a nerve structure / receptor, and it's referred to as the lamellar corpus. Okay, so it picks up tactile surfaces, allows you to feel different tactile surfaces. Okay, so, and then at the bottom, we have the hypodermis, the subcutaneous layer, and we have the vascular plexus. See all of this? These are veins and arteries, and they're big veins and arteries that branch into smaller arterioles and smaller veins. And basically, this supplies all the oxygen and nutrients for the skin. So the dermis has 2 layers, papillary, reticular. Papillary is that egg crate, kind of finger-like projection shape structure. The reticular is the rest of it. Okay, it has nerves, blood vessels, hair follicles, oil glands, sweat glands, and technically there are lymphatic vessels. And of course, you want to know the anatomical structures that we reviewed. Now, this shouldn't be surprising. 80% of the dermal thickness is made up by the reticular layer. And we can clearly see that here. It takes up most of the dermis. Now, inside there's connective tissue that has elastic fibers that allows the skin to stretch and recoil. Collagen fibers that provide elasticity, strength. It allows your skin to be resilient. It also helps bind water molecules and keep skin hydrated by locking in moisture. Okay, now the subcutaneous hypodermis area is referred to as the cutaneous plexus. The cutaneous plexus is, in other words, the dermal vascular plexus. It's just more in reference to the very specific veins and arteries, the big set right there. Okay, and then at the very, very bottom of all of it are these little fat cells, adipose tissue, which provides insulation. It absorbs shock and retains heat when necessary. In the reticular layer, we have something called cleavage tension lines. Now, ultimately, their pattern is from collagen fibers running parallel to the skin. So this is a print of all of these cleavage lines, and externally you can't see them, but they're important here and in general because surgeons use those cleavage lines to make incisions. They run these incisions parallel to cleavage lines because they know that if you cut in the direction of these lines, such as, let's say this way, shoulder surgery. Okay, it's going to heal a lot faster rather than if they were to cut a different way.
Our skin, also called the integument, is an elastic, durable covering protecting our body and is our largest organ. If the skin of an average-sized adult were spread out flat, it would cover an area of approximately 2 square meters and weigh about 4.5 kilograms, the size and weight of a medium-sized rug. Skin tissue grows faster than any other organ tissue and is constantly renewing itself by growing new skin cells and sloughing off old ones. This includes our hair, finger and toenails, which are composed of the same type of cells as our skin, and, along with our skin and glands, make up the integumentary system. The integumentary system consists of 2 components: the skin, called the cutaneous membrane, and accessory structures, which include hair, nails, sudoriferous or sweat glands, and sebaceous or oil glands. We will examine these components one at a time. The skin's functions include protecting the body from bacterial invasion and from drying out, regulating body temperature, providing sensory reception, synthesizing vitamin D, excreting waste products, and serving as a reservoir for blood and nutrients. The cutaneous membrane consists of an upper layer called the epidermis, an underlying or basement layer called the dermis, and connective tissue called the subcutaneous or hypocutaneous layer. The epidermis is made up of 5 layers called strata: the stratum corneum, stratum lucidum, stratum granulosum, stratum spinosum, and the stratum basale. It is firmly attached to the underlying dermis by a membrane called the basement membrane. Accessory structures belonging to the integumentary system include hair, sebaceous and sudoriferous glands, and nails. There are approximately 5 million hairs on our body. The fine, soft hair that covers our limbs and most of our body is called vellus hair. The thicker, stiffer hair that covers our head, including eyebrows, beards, and mustaches, is called terminal hair. The only totally hairless areas on our bodies are our palms, soles, and lips. Hair grows out of a structure called a follicle. Follicles extend into the dermis and even the hypodermis, surrounded by a thin layer of epidermal cells. Stem cells divide at the bottom of the follicle, and as these cells become keratinized, they form a hair shaft inside the follicle. Above our skin's surface, hair consists of dead, keratinized cells. Only the root of the hair inside the follicle is alive. A sensory nerve fiber connected to the base of each hair follicle enables us to feel the movement of a single hair. This contributes to our skin's sensitiveness to touch and temperature. Each follicle also possesses a tiny muscle that can contract in response to emotions such as fear or rage, or in response to cold, which pulls hair erect and causes what we call goosebumps on the surface of our skin. On average, 100,000 hairs grow on our heads at the rate of about 1.3 centimeters per month. These hairs generally live about 3 to 4 years, and in some people would grow to nearly 2 meters long if left uncut. An adult loses about 100 of these hairs each day. Most of them grow back, except for men going bald. Many men after the age of 40 find their hair receding on the top of their skulls, and some men become totally bald. This is caused by changes in the level of sex hormones in males and is called male pattern baldness.
Okay, the next thing we're going to talk about are the 3 pigments that contribute to skin color: melanin, keratin, and hemoglobin. Melanin blocks UV damage and she blocks DNA from getting damaged from the sun. Ultimately, it protects your DNA. Typically, when we're out in the sun exposure stimulates melanin production, which is the reason why we get tanned in the sun, right? And so that makes sense. Now, if we have a high amount of melanin in our skin, the darker the skin will be. Low melanin, the lighter the skin will be. Now, freckles and moles and things like that are just an accumulation of melanin. Keratin. We see this mostly in our palms and soles, but we still have yellow and orange pigment inside of our skin. And hemoglobin. Basically, hemoglobin shows through fair skin. And it gives off this kind of pink color because hemoglobin is associated directly with red blood cells. So what can happen in situations where skin color is affected? There's a couple of diseases that I want to talk about. Cyanosis. Cyanosis is when the skin has low oxygen. So in general, the rule with oxygen and hemoglobin is as follows. Okay. The higher the oxygen level, okay, increased oxygen, oops. So oxygen binds with hemoglobin in the blood. Okay, so the higher the oxygen concentration / hemoglobin, the more red your blood will be. It will give off a visibly red color. However, the opposite is true when there's low oxygen. When oxygen is low, we get the opposite effect. Okay, what's going to happen is your blood won't have this reddish color after all. In fact, it'll have a bluish color, more like purple. Okay, so oxygen has a direct relationship with your blood because it binds with hemoglobin. Hemoglobin is a protein and it has iron in it. And when oxygen binds to hemoglobin, that iron will rust, creating red blood. Okay, you take away that oxygen and reduce the concentration of oxygen, there's not going to be a significant amount of oxygen to cause this rusting of iron that's within the hemoglobin. Instead, the blood will shift over to this bluish color. The other thing in disorders of the skin is jaundice. So a lot of babies sometimes are born with jaundice and they have to put them under a special NICU light. And it's basically a liver disorder, but it causes this yellow tint to the skin color. All right, now we discussed accessories of the integumentary system, and hair is one of them. Hair is dead keratinized cells. They do have, hair does have an important role in protecting our body. It warns our skin of insects. It helps protect our head from trauma. It protects from heat loss, and it also shields your skin from damaging UV sunlight. All right, now we're going to focus on the hair structures. Now we've already gone over a couple of them, but I want to zoom in at a couple more things that we didn't talk about. So notice that the cutaneous plexus has a network of capillaries right there inside of the hair follicle, supplying oxygen and nutrients to the hair itself. Okay. Now, ultimately, like the bottom part of the hair is referred to as the hair bulb. Of course, these are the hair follicle receptors. We technically have a hair follicle wall. I'm not really too concerned about, the hair follicle wall and that angle of it. I'm more concerned about the actual hair follicle receptor, the erector pili muscle responsible for contracting and for goosebumps, and of course the hair papilla, the capillary, the knot of capillaries that supply nutrients to the hair. Okay, of course, our sebaceous gland, this oil gland, it releases oils onto the hair, and it's part of the reason why sometimes if you don't wash your hair, it gets greasy, right? That oil is coming from these guys, these little clusters called sebaceous oil glands. Okay, so the structures are pretty straightforward. You shouldn't have too big of a challenge with them. You just want to know them, memorize them. Now, as for the structures of the nail, I don't go too much into this. I just want you guys to know that the nail is indeed part of the integumentary system. Okay, now I want to get this straight. We have glands, and I've mentioned two. Okay, the most recent one was this one, the sebaceous oil gland. Now, how do you know the difference? Well, let's look. The sebaceous oil gland is connected to the hair follicle. Always connected. You can see it here, too, and there. Excellent. Okay, so that's how you identify it. There's no other gland that's connected to a hair follicle. It's your sebaceous oil gland. Its job is to lubricate the skin, the hair. It has antibacterial properties, and mostly it releases that oil that we need to keep our skin and hair soft. Okay, now let's take a look at this one. The eccrine sweat gland. It looks like this knot of convoluted tubules. And notice this, that this little gland has a tubule that goes right out of the skin. Okay, ultimately, that's how you identify it. It's this wound up, convoluted knot, okay, and it connects directly to the external surface of the skin. Okay, an apocrine sweat gland looks kind of like the eccrine sweat gland, right? It's convoluted and knotted, so how do you know the difference? This is how. This one is bigger. The apocrine sweat gland is bigger. And notice where it connects. The tubule is going to connect to the hair follicle. And it's this straight, windy, convoluted tubule, and then it gets all coiled up down here. Okay, so you want to know your eccrine sweat gland, your apocrine sweat gland, your sebaceous oil gland. So why does this whole chapter matter? Why do you need to know the integumentary system? Well, some of the reasons why is because you need to understand burns. When you guys get to your field in nursing or PA or medical, either way, you might work in a trauma unit. You'll do rotations in a trauma unit for sure, and you might see these burns. And there's a way to distinguish first degree, second degree, and third degree burns. Clearly, the first and second degree are not as severe because the dermis is not fully burned. The third degree burn has reached the dermis and it's pretty damaging. The other reasons why we need to know about the integumentary system is to understand skin cancer. We have 3 major types of skin cancer. The first is the basal cell carcinoma. It's the least malignant. It's the most common. A doctor can remove something like that pretty easily. No big deal. Okay, now the second is the squamous cell carcinoma. Okay, these ones are a little trickier because they can metastasize. However, there's usually a good prognosis here. If it's treated early on, they can just hit it with radiation therapy or just cut it out. Now, the scariest one, the most dangerous one, the one that you never want anyone to have is melanoma. It's cancer of the melanocytes. It's the most dangerous because it's highly metastatic, meaning it's aggressive and it's resistant to chemotherapy, which is one of our most important cancer drugs and most effective. And so therefore, there's got to be another solution. If chemo doesn't work on this, then we bring in immunotherapy, which is, it's not that new. It's pretty old actually, but it's becoming more widely used, immunotherapy to treat cancer. Other disorders of the skin are acne. Acne is when the sebaceous glands, sebaceous oil glands, are inflamed. Whiteheads are when they're blocked, and once oxidized, they become blackheads. Now this one is interesting. Sometimes if a sebaceous gland is overactive, which tends to happen in newborns, they'll get something called a cradle cap. See this little, all that skin? I mean, it will flake off and fall off, but I don't think it feels so great for the babies. It's usually pink and there's little lesions, and I think it's slightly painful for them, but luckily it does flake off and go away. Okay, that is the end of the integumentary system. Please review the chapter in your textbook, and I'll see you next time.